Awesome. Now, without further ado, I'll pass it over to James.
Good afternoon, everybody. My name is James Weinberg, for those of you I haven't met, and I do see some folks on this meeting that I do know, and I see some people that I don't recognize. So I've been at Carnegie for just almost exactly a year now. I came in when Claris joined the Carnegie family, and I work on product development. And those products range from solutions that leverage artificial intelligence to data analysis. My background is largely in market research and data mining, but also in digital marketing. And so in higher education marketing, I've worked across a lot of different departments, and I feel like I have a pretty good lay of the land about how data impact a lot of what we do and a lot of what we should do. So I'm a total nerd, but there are a couple of other nerds that sometimes think I'm kind of cool. So I like those nerds. And my Carnegie archetype is the exploratory and brilliant originator. I am yellow, orange, and green. So we can move on, please. So first of all, I want to apologize for a little bit of a bait and switch. About a week ago, I decided to make this presentation focused a bit more on just general data analysis techniques and tools in general, and to take the focus away from solely Excel. Now, that being said, Excel will figure prominently into this discussion, but I wanted to expand it a little bit more and make it, I think, hopefully more exciting and useful than it would have been. So if you were excited about what you thought you were getting into and this wasn't it, I hope that you'll be more excited. So with that, we can continue, please. All right, so today's agenda is we start with why anybody should care about this, then what we can do with data, how you can do it, and then we'll open up to questions and answers. So if we can move on. Why should I care? Okay, well, there are several reasons. When analyzing data effectively, you can simply tell new and better stories. Some interesting facts and other reasons that you should care are that Carnegie has a lot of data. When you think about the work that we do, the digital marketing campaigns, the market research that we collect, the surveys and focus groups and all the things that go into darts, almost I should say really all of the work that we do is contingent upon collecting data and providing data, right? These data ultimately, especially in certain departments, Slate, for example, CRM data, that tells us who people are, the types of activities that they're engaging in with institutions. In digital advertising, of course, we track, the extent to which people click on ads and fill out forms on landing pages. So data are all around us, and they are frequently used to track ultimately whether Carnegie is a successful partner. So data can tell very interesting stories depending upon how they are analyzed. And this is important because we pride ourselves here at Carnegie on being storytellers who can connect well with people, right? We pride ourselves on human connection. And as ironic as it is, the best way to connect with people at scale is to analyze data to better understand how we can create personalized connections with people whom we don't know yet, or create better connections with the people whom we do know. So how are data used to tell different kinds of stories? Several ways. Data can be used to predict what's likely to happen. So as you know, Carnegie has services where we might analyze historical enrollment data with the hope of being able to help institutions predict which future applicants are likely to enroll. We also use data to classify, and our archetypal Carnegie Chem is a great example of that. So if you remember, we all took a survey, and that survey categorizes us or classifies us into different groups that have different characteristics. Another word for this that you hear often is personas or segments. Another way that data are often used, and this happens in our everyday lives, are to recommend. And we'll take a look at that in a second. Here's the great news. And let me back up by telling you that you might be thinking at this point, oh gosh, I don't like math. I don't like stats. I don't know how to use computer programs that require coding. Neither do I. I am not a math person, really. I floundered in statistics in college before I actually had a true use case for it. And I know enough about coding to be dangerous, but I am by no means an expert. And so I got into all of this because, simply put, I enjoy solving problems. And anytime I've been given a business challenge, or in some cases a personal challenge, whenever I have data that can be used to help answer questions, I have learned how to use it. And I've learned how to use it using free open source tools that do not require any knowledge of coding, any knowledge of statistics. If you can use Microsoft Word and PowerPoint, you can use these tools. And while we're not going to dive deeply into how to use these tools specifically, I am letting you know that if you're interested after this presentation in diving in more deeply, I can help you. I can show you the tools. I can show you how to use them. And there's all kinds of great resources. So please don't be intimidated with any of this, because I promise you, if this interests you, you can do it. All right. So what can I do? So there are all kinds of questions, again, that we can answer, and I just touched on a couple of these. So within our work, we can use data mining or advanced data analysis, or data science, whatever. There are many terms for this type of work. But we can answer questions including which students are likely to apply to our school, which students are likely to enroll, which current students are likely to drop out, what alumni can be used, what alumni are likely to donate. The exact same statistical models can be used to answer all those questions. It's just that the input and output data, which come from oftentimes an Excel spreadsheet, change, right? So we might look at historical enrollment data to predict who's likely to enroll. We would look at past giving data of alumni to predict which current alumni might be good prospects to approach for future giving. Exact same process. Another type of question we can answer is, what segments of our prospective students exist? And this is where personalization comes into play. And when you hear personalization, what that really means is, how do we take a huge group of people that, quite honestly, we can't individually communicate with, and group them into buckets that enable us to create messaging that's likely to be compelling. So, for example, let's say that we have 10,000 students on our inquiry list, right? It might not be possible to send individualized email communications, let's say, to all 10,000. But what we can do is, based upon where they live, how they identify in terms of gender, race, ethnicity, the types of test scores and academic interests they have, extracurricular interests, et cetera, we can create segments or personas where maybe we distill those 10,000 people into 5 key groups, where one group is, 17 to 19-year-old, predominantly women who live in Florida, who are interested in accounting programs. Several of them played volleyball in high school, et cetera. That's how we can basically boil down a huge group of people into manageable segments that make communications more personalized, but also manageable. Moving on, please. Okay. I think that we have the wrong version of the presentation. So I am going to quickly share my screen and go to the updated version. Again, sorry about the bait switch. All right, so where were we here? Okay, so let me just get in the slideshow mode. All right, so the other types of questions that we can answer are questions that get answered about us all the time, right? So let's look at how we experience these types of data exercises in everyday life. Anytime you go to Netflix or Amazon or a service like that, when you get a recommendation like here, I love that this is Sesame Street, by the way. You can see here, because you enjoyed Born into Brothels Rock School, we think you'll enjoy The World According to Sesame Street. How is that recommendation made? Basically, a ton of data have been analyzed, and it's literally just looking at correlations or common occurrences. So, for example, we might find that on Spotify, people who listen to the Grateful Dead, in many cases, also listen to the Allman Brothers, right? They can understand that by looking at, common common songs that have been selected, right? So, therefore, if you have listened to the Grateful Dead but never listened to the Allman Brothers, Spotify will probably recommend that you listen to the Allman Brothers. It's simple correlation. Anomaly detection is another type of data science application that we are probably seeing. And this is an actual credit card alert that I got recently. I blocked out my number and the amount just because that's top secret. But what happened was a purchase was made in an area and at a time and with a vendor that didn't match my normal spending patterns. So Capital One sent me an alert asking if I recognized the purchase. In fact, this did turn out to be fraudulent. Somebody hacked my card. And the reason that Capital One was able to figure that out is because they looked at my entire purchasing history, where I tend to purchase things on the credit card, for how much, with what vendors. And when they saw something that didn't look right, that is called anomaly detection. Again, something that's very, very, in fact, easy to do. Okay. So finally, we can also understand by learning more about this, what makes Carnegie, right? We know that our archetype model is really a philosophical underpinning for a lot of the work we do, right? It is what helps us define and execute on our desire to better have human connection. Again, I showed you some ways that our FAO team, for example, might use historical data that has financial aid information so they can help schools best understand what types of award levels should be offered to admitted students so that institutions can minimize their financial outlay while maximizing the number of students that they get. That's another great use of data that happens at Carnegie every day. So one of the things I want you to realize, and maybe some of you are thinking, well, we have departments at Carnegie that do these things, and I'm not in them, so why would I care? So the answer to that is, anytime you have a data set, regardless of where you work, you can learn ways to look at that data in different ways that will potentially make you better at your job. It'll make you perhaps more strategic in how you can communicate either with your colleagues internally or with external facing clients. But honestly, taking an Excel spreadsheet, any Excel spreadsheet that has campaign data, that has enrollment data, there are simple ways that you can quickly learn what stories exist in those data and what that might mean for any given project. And anybody can do this. So we kind of looked at this. Okay, so I'm going to talk to you a little bit about the process of data mining. There are several steps, and honestly, the first one seems kind of obvious, but it's understanding what business we're in, right? What are we trying to do? What problems are we trying to solve? What challenges are we facing? So in higher education, of course, we've all heard about this enrollment cliff, and even before the enrollment cliff, with just increased competition and increasing tuitions, it was still necessary to want to be able to predict who is most likely to enroll, but that is becoming increasingly important. It's also becoming increasingly important to be able to predict who's likely to be retained, because as the number of available applicants decreases, it's going to put much more of a burden on schools to try and keep the students they do have. Again, that is a data related challenge that can be solved with analysis. So again, what questions do we need to be able to answer? That's really what we need to think about first when we understand the business that we're in. Step two is understanding the data that are available to help us answer those key questions. So if we wanted to be able to predict which students are at risk of dropping out, we would need to see historical data that shows which first-year students did and did not return for year two. If we're trying to predict enrollment, we would need to see historical data that showed admitted students who did and did not enroll. So how do we collect the right data? Well, we have to have, first of all, good systems in place. Slate CRM, for example, is a system that when used well can produce excellent data. Other CRMs, Pipedrive, HubSpot, all the same. There's great data in Tin Man. Our institutional clients sometimes have robust and good data, but these data can come from CRMs, they can come from student information systems, they can come from Excel spreadsheets that are scattered around somebody's desktop. There are all kinds of ways that we can get data, and typically they come in, a database or, a CSV file. So understanding how to use Excel, even at, an intermediate level, can often be very helpful here. The next is, how do we analyze and classify data? So data tend to be either categorical in nature, and think about a race and ethnicity, for example, in a database of prospective students, right? Labels such as white or Caucasian, Black, Hispanic, or Latino, those would be considered categorical data, sometimes also known as text data. Other types of data are numerical. They might be things like GPA, right? 4.0, 3.5. Then there are dates and times, right? Sometimes, for example, in predicting enrollment, it's really predictive how long it has been since a student applied versus some other, maybe the current date. So data are always messy. They are always messy, and you'll hear from people who work with data that typically about 80% of a data-oriented project is in cleansing and aggregating data. So whenever data are missing or inaccurate, it can cause huge problems in developing models that can be used, again, to predict or classify. Here's an example. I worked with a school one time where it was required to have student birthdays. Now, there was some sort of issue where the system wouldn't allow blank data. So anytime the school didn't have a student's birthday, they put in they put in January 1st. They put in January 1st, 1900. You can imagine that, again, in the calculation of age as a potential predictor of enrollment, that caused a big problem when all these prospective students were 101 years old, right? So that's the kind of thing that's easy not to catch. And if you don't catch it, you will have problems. Other things are that sometimes data look like one thing, but they're not. Example is zip code. Anytime you load a spreadsheet into a data mining software, it will think that zip code is numeric, meaning that zip code 99999 is bigger than zip code 06107, right? That's not the case. Zip codes are in fact categorical. It's a label that doesn't have a numerical scale or weight associated. So there are all these little kind of tips and tricks, and the more you work with data, the more that you will start to understand these things. But my point here is that being excited about looking at data, a lot of these types of issues can be spotted with the naked eye and don't require, there are issues with data that a machine won't catch, that a human will, who is curious, who's looking to solve a problem, who has good attention to detail. So a lot of this process is human driven. Even though machines and algorithms eventually crunch numbers, there are a lot of human decisions that are made both on the front end and back end of these types of data projects, excuse me. So let's start with, again, something that we know and use today, Excel. Again, Excel and specifically a CSV file will always be something that you will probably be presented with in a data analysis project. Here's an example of a survey that I did of a school a while ago. You're just seeing a subset of questions where they were asked their level of familiarity with the school. And we could see, again, these are levels of familiarity. And then on a 5-point scale, ranging from 1 to 5, where 5 was the highest, they were asked why it was important for them to pursue a degree. So, was it for intellectual fulfillment, to get a high-paying job after graduation, to prepare for grad school, etc. When you have data like these, you can end up creating personas. So what you'll see here is, again, this is an aggregation. It's a grouping of tens of thousands of prospective students. If you remember, it's not practical to be able to think that we can communicate individually with all of them. So we have to create personas, which are representatives of manageable subsets of a large group. So in this case, what we have here, if you remember that those questions of familiarity, here was one prospective student persona. And the persona blends attitudinal, behavioral, and demographic characteristics that came from the CRM, from the institute, from the survey that you saw. And so again, you can see here that in the survey, we asked about everything from music preferences, literature preferences, film preferences, social media use. And this is nothing more than a statistical exercise. But the fun part is when you get the statistics and you actually have to get creative and make a composite of what all those statistics mean. So there's a very creative side to many of the outputs. If you think about our Carnegie's archetypal model, our darts, right? Those are kind of creative interpretations of what numerical data gleaned from surveys mean. So you can see how there is room here for very mundane math, but also very fun kind of creative outputs. All right. Again, I'm not going to dive too deeply into this part, but what I want to tell you is that if you can use Microsoft Word, if you can use PowerPoint or Excel, anything that is basically drag and drop where you do not have to know anything about how to create computer code, you can do this. I literally was tutored by some people years ago who got me started. And then I just found some tools and found some resources and just started practicing. And again, no math. I mean, you have to understand some concepts, but you don't have to be a statistics expert to do this. You don't have to be an advanced mathematician, and you don't have to know anything about how to write computer code. The tools get better all the time, but what's important, again, to note is that these tools only help you answer the right questions, and only we can ask the right questions, right? So again, going back to what's most important in all of this, it is curiosity. It's wanting to solve problems. It is being interested in looking at information and wanting to see that information in new ways, even if it just initially looks like a really boring spreadsheet. It is understanding the business that we're in, the trends that are coming, the challenges that we face today and that we're likely to face tomorrow. So there's honestly a lot more thought and strategy that goes into any of this. All these tools do is spit out numbers and models. And if you put in, frankly, garbage that is meaningless, it'll spit garbage out, right? You've probably heard that phrase, garbage in, garbage out. So what's most important here, much more than learning how to use these tools, asking the right questions, being interested in solving problems, and understanding how you can access the data that you need and process it so that you can understand it yourself, provide it back to our clients, use it internally with our team members to start maybe thinking about some of our information in different ways. But again, I really want to just reinforce the fact that I was so intimidated by this whole area when I was first presented with the idea of it. And I assumed I was going to fail quickly and thoroughly. And with just some effort and some excitement about learning something new, I've gotten good at this. But again, the tools get better all the time. They get easier to use. And I just want to end by, before we go into questions, by saying, if any of you are interested in following up with me, I'm more than happy to, provide you with some tools, resources. I'm participating in the mentoring program with some folks where we're talking about data analysis. So if anybody's interested and wants to reach out, please do. And with that, I think we will go into questions and answers. I don't know what time it is here. Oh, wow. That was pretty good timing.
Yeah, great timing. We have 2 questions in the chat already. The first is, what's your favorite Excel function?
My favorite Excel function is, I just love VLOOKUPs. I mean, it's old school, but there's just something just so fun about the VLOOKUP. Even though I know that there's probably, if Ryan Popper's on here, he's gonna say index match is way better, and it is. But VLOOKUP was the, here's why I like it. I got fired from a job in like 2001. I was working at this company, Ernst & Young, you probably know it, as a financial analyst, and I got promoted from my entry-level job into a job that required advanced Excel skills. I had literally never used Excel, and VLOOKUPs were basically the foundation of these reports that I had to produce, and I had no idea what I was doing. And I presented this absolutely ludicrous report to like the head of like the lead partner in my business unit, and got pretty much laughed out of his office and then fired. So that made me want to learn Excel and specifically VLOOKUPs.
We're getting a lot of love for XLOOKUP, I will say.
XLOOKUP is really cool too. Yeah, that is super cool.
Another question, do you have any app recommendations for data analysis?
I do. One would be called RapidMiner. That is a tool, again, that is fully drag and drop. It's if you can create a flow chart, you can create a super advanced data analysis pipeline. It is my personal favorite because that it really reflects how I think, which is kind of a visual flow charty, diagrammy kind of way. So if you can click and drag blocks onto a canvas, you can do just wild statistical things that are going on sort of under the hood. So that's one. Another is KNIME, or Name, KNIME, same kind of interface as RapidMiner. Object-oriented, kind of click and drag and connect things. It's kind of like a Lego set. There's a tool that we use here at Carnegie called R. R is a statistical programming language that also has some interesting like graphical user interfaces that can be applied to it so that you don't have to know how to code. Those would be the 3 I would probably recommend starting with. And also, I mean, there's some really cool stuff in Excel. I mean, a lot of times really good questions can be answered just as well with a pivot table as with an advanced data analysis pipeline. In fact, Gary and Ryan and Tyler and myself were recently on a call with this crazy advanced like statistical group, and they were presenting this potential product to us. And the whole time I was thinking, couldn't I just do a pivot table of the zip codes where they've had the highest percentages of enrollment? And I'm pretty sure the answer is yes, and that would have saved these people like a lot of computing resources. So there's that. I love pivot tables too in Excel. Love them.
Love it. Well, we are at time, so I'm going to wrap us up here. But James, thank you so much for all of the knowledge and wisdom you shared with us today. And thanks everyone for coming.
My pleasure. Thanks, everybody.
Thanks, James.